a Harvard scientist is sounding the alarm. An interstellar visitor, 3I Atlas, is shedding metallic alloys that shouldn't exist. Real data from our best telescope shows atomized nickel streaming from its core, but with practically zero iron, a chemical fingerprint that defies everything we know. Harvard's Avi Loeb is asking the question no one else wants to. If these metals aren't natural, what does that mean? The answer could upend our place in the universe, so let's explore this together. The discovery of 3I Atlas. What would you do if you saw something moving at 130,000 miles per hour that wasn't supposed to be there? On July 1, 2025, the Atlas survey team in Chile spotted a faint, fast-moving speck. The math instantly told a story that didn't fit any known playbook. Its path wasn't just a long loop, it was hyperbolic, with an extreme eccentricity that confirmed it was a visitor from deep space, moving too fast for the sun to ever capture it. This wasn't a comet on a return trip. Astronomers combed through archival data and found earlier images, firming up its trajectory. The object was born far beyond our solar system, possibly somewhere near the galactic center. By the time it was discovered, it was already inside Jupiter's orbit, making a one-time slingshot around our sun before it shoots back into the void. Its incredible velocity confirmed it. 3I Atlas is only the third confirmed interstellar object ever seen, a messenger from another star that will never return. This isn't just a rock, it's a clue from an unknown part of the galaxy. The nickel mystery. Here's where the story takes a sharp turn into the unknown. Almost as soon as telescopes focused on 3I Atlas, they saw something that shouldn't be there. Data from the Very Large Telescope in Chile revealed a strong spectral line for nickel, a cloud of it vaporizing off the object's core. But what was missing is what has scientists stunned. There was virtually no iron. That's not just unusual, it's unheard of. In every comet, asteroid and meteorite we have ever studied, nickel and iron are cosmic partners. They are forged together in the hearts of dying stars and locked into the same minerals. You don't find one without the other. Yet 3I Atlas is shedding pure nickel vapor, with iron being conspicuously absent. Harvard astrophysicist Avi Loeb, known for his bold theories, was the first to publicly highlight how bizarre this is. He argues that separating nickel from iron on an industrial scale is difficult on Earth. In nature, it's considered next to impossible. This isn't just a small anomaly. The nickel-to-iron ratio in typical solar system objects is well established. On 3I Atlas, that ratio is completely off the charts. It's a chemical fingerprint that matches nothing we have ever seen. Carbon dioxide dominance. Just when the nickel-iron problem had scientists scrambling, the James Webb Space Telescope delivered another bombshell. Pointing its powerful infrared instruments at 3I Atlas, a team of astronomers analyzed the gases in its coma, and found that carbon dioxide was completely dominating the mix. The measured carbon dioxide to water ratio was a staggering 8-to-1, the highest ever recorded for any comet, whether from our solar system or beyond. To put that in perspective, typical solar system comets have CO2 levels around 4% of their water content. Here, CO2 is the main ingredient. This wasn't a fluke. The readings remained consistent across multiple observation sessions as the object neared the sun. While other gases like carbon monoxide were present, nothing came close to the CO2 spike. This kind of chemistry just doesn't align with our models of comet formation. Some researchers propose that its unique composition is the result of being cooked by cosmic rays over a billion-year journey. Others wonder if it's a clue to the specific conditions of its home star system. But the question remains, does this unprecedented chemistry point to nature at its most extreme, or is it another sign that something else is at play? The Oumuamua precedent. This isn't the first time an interstellar visitor has broken all the rules. Back in 2017, the first ever confirmed interstellar object, named Oumuamua, left astronomers scratching their heads. It was traveling at high speed, had a bizarre, highly elongated shape, and most mysteriously, it accelerated away from the sun without any visible reason. Comets accelerate due to outgassing, where melting ice acts like a thruster, but Oumuamua had no visible tail or coma. This is where Harvard's Avi Loeb first entered the public debate. He controversially suggested that the best explanation for Oumuamua's non-gravitational acceleration was that it was an artificial object, perhaps an alien solar sail designed to ride the pressure of starlight. While most of the scientific community proposed natural explanations, like outgassing of hydrogen ice, or its composition as a nitrogen iceberg, none of the theories perfectly fit all the observations. Oumuamua left our solar system before we could get a better look, leaving a legacy of unanswered questions. Its appearance primed the scientific community to expect the unexpected. Now, with 3I Atlas, we have a second data point that defies easy explanation. Ancient sky metal. Humanity's fascination with metals that fall from the sky is not new, it's ancient. Over 5,000 years ago in ancient Egypt, craftsmen hammered tiny beads from a mysterious iron that they didn't mine from the earth. Modern analysis of these beads from the Giza cemetery reveals a nickel content of nearly 30%, far higher than any terrestrial ore. This was the unmistakable signature of meteoritic iron. The story gets even more incredible with the dagger found in the tomb of King Tutankhamun. Discovered in 1925, the pristine iron blade was a mystery for decades. Finally, X-ray analysis confirmed its celestial origin. The blade contained 11% nickel and traces of cobalt, a composition that matched iron meteorites. The Egyptians even had a name for this divine material, iron of the sky. It was rarer and more valuable than gold, reserved for pharaohs. This history matters because it establishes a fundamental contrast. Terrestrial iron ores almost never exceed 4% nickel. Meteoritic iron, however, is rich in it. The same questions our ancestors faced, what is this strange metal and where did it come from, are echoing today as we analyze the impossible alloys of 3I Atlas. Kilonova formation theory. So, if the metals on 3I Atlas are natural, how could they have formed? There are a couple of cosmic forges violent enough to potentially create such exotic materials. The first is a kilonova, the cataclysmic explosion that occurs when two neutron stars collide. These events are among the most powerful in the universe, and for a few brief seconds they create conditions perfect for the R process. A rapid-fire sequence of neutron captures that forges elements heavier than iron. In the chaos of a kilonova, the normal rules of element production can be broken. Some theoretical models predict that the debris cloud from such a merger wouldn't be uniform. Instead, it could contain pockets of matter with strange elemental imbalances, regions that are incredibly rich in elements like nickel, but poor in iron. If 3I Atlas condensed from one of these exotic debris patches millions of years ago, it would carry a chemical signature unlike anything from a standard supernova or our own solar system's formation. This theory provides a potential natural explanation, but it relies on an event that is both incredibly rare and violent. Asymmetric supernova theory. There is another natural forge in the cosmos violent enough to potentially explain 3I Atlas's strange chemistry, an asymmetric supernova. Not all stars die in neat spherical explosions. Some rip themselves apart in lopsided blasts that fling elements out in jets. The supernova remnant, W49b, is a perfect example. X-ray maps of W49b from the Chandra Observatory show that iron is packed tightly near the remnant's core, while other elements like sulfur and silicon are distributed more broadly. This kind of uneven explosion completely changes the rules of how metals are scattered into space. In these chaotic events, the inner layers of the star, where iron and nickel are made, don't mix evenly. Instead, high-speed plumes can punch through the star's outer layers, carrying specific elements with them. If nickel happens to be concentrated in the path of one of these jets, it can be ejected in bulk, leaving most of the iron trapped behind. If 3I Atlas formed from a fragment blasted out by such a supernova, it could have started its journey as a chunk of nearly pure nickel. This provides a second plausible, though very rare, natural path to its bizarre composition. Statistical improbability. Beyond its strange chemistry, there's another red flag that has Avi Loeb and others asking serious questions: the object's trajectory. According to Loeb, the probability of a random interstellar object passing so close to several planets in our solar system, Venus, Mars, and Jupiter, in a single flyby, is astronomically low. His calculations put the odds at about 1 in 20,000, or 0.005%. For an event this rare to happen with only the third interstellar object we've ever detected is, to him, statistically suspect. Furthermore, the object's path is nearly aligned with the plane of our solar system, but it's moving in the opposite direction of the planets. This retrograde orbit allows it to sweep past the inner worlds in a way that looks almost like a survey mission. To add to the suspicion, 3I Atlas reaches its closest point to the Sun on the far side from Earth, making it incredibly difficult for us to observe when it's most active. Critics argue that in a vast universe, rare events are bound to happen. But Loeb counters that when multiple anomalies, the metals, the chemistry, and the trajectory, all point in the same strange direction, the possibility of an artificial origin must be taken seriously. The Golden Record Parallel. Could 3I Atlas be a message in a bottle? In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record. This was a project led by Carl Sagan, intended as a time capsule for any extraterrestrial civilization that might find it thousands of years from now. The records contain sounds and images of Earth, music from various cultures, and scientific diagrams, a snapshot of humanity etched onto a durable physical object. Sagan said, "The launching of this bottle into the cosmic ocean says something very hopeful about life on this planet." Now consider 3I Atlas, an object loaded with alloys and compounds that don't fit natural recipes on a trajectory that seems too precise. The parallel is striking. What if its message isn't written in grooves on a record, but in the very ratios of its elements? A physical archive designed to survive a journey of millions of years. If its composition is intentional, then 3I Atlas isn't just a visitor. It's a courier carrying a record of another world's chemistry, and maybe even its technology. Atomic messages. If 3I Atlas is a message, how could it be written? The answer might lie in isotopic encoding. Isotopes are versions of an element with different numbers of neutrons. On Earth, scientists can already store information at the molecular level by creating unique isotopic fingerprints. By precisely controlling the ratios of different isotopes in a material, you can create a pattern, a kind of atomic QR code that would never occur in nature. An advanced civilization could theoretically bake a message into a metallic object, making it durable enough to survive a journey of millions of years through interstellar space. Such a message would be immune to the cosmic noise that can degrade radio signals. The information would be in the fine print of the object's chemistry. This is why every scrap of data from 3I Atlas is being scoured for these hidden patterns. Are the isotope ratios what we'd expect from a kilonova, or do they show a level of order that points to intelligent design? We're not just looking for a rock anymore, we're looking for a signal hidden in matter itself, a message that has waited eons to be read. The story of 3I Atlas leaves us at a profound crossroads. On one hand, we may be witnessing an undiscovered, violent natural process, a kilonova or an asymmetric supernova capable of creating alloys we once thought impossible. On the other hand, the combination of inexplicable metals, extreme chemistry, and a statistically improbable trajectory has forced serious scientists like Avi Loeb to consider an engineered origin. This isn't just a theoretical debate, it's a real object with real data that is breaking our models of the universe. Either way, our understanding has to expand. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cosmic mysteries. Thanks for watching Sci and Why.